Welcome to this video. In previous videos, I taught you how to graph horizontal and vertical lines, given the equation of a line, how to graph a linear equation if it's given in slope-intercept form, how to graph a linear equation in standard form, either by rewriting it in slope-intercept form or by determining the x and y intercepts. In this final video, in Chapter 4, Section 4, I will teach you how to solve systems of linear equations by graphing. This is a summary of how to solve a system of linear equations by graphing. Notice that you can use either of these methods, the slope-intercept method or the x and y-intercept method, to plot your graph. It's up to you. It's important that you graph both lines on the same set of axes. Once you've plotted both lines, you need to determine the point of intersection and write it as an ordered pair, and then at the end you can always check the solution in both equations. Let's get started. Before we do a specific example, I want you to think about this. I encourage you to pause the video and answer these questions on your own before we proceed. The question is, how many times can two straight lines intersect? Can you draw two straight lines, not curved lines, but straight lines that intersect exactly once? How about two lines that never intersect? How about lines that cross more than once? Again, pause the video, see if you can do that, and then unpause the video. Two lines that intersect exactly once might look something like this, or maybe something like this, or something like this. That's pretty simple. Two lines that intersect is also usually pretty straightforward. You might recall that we call these parallel lines. What about two lines that intersect more than once? Most people get stuck here. Well, here's one line. What if I drew a second line completely on top of that first line? Again, I'll do it again. I draw one line, and then I draw a second line that completely overlaps the first line. That's how two lines can intersect more than once. So let's write how many times can two straight lines intersect. They could intersect at exactly one point, or exactly once. They could have zero intersections. In other words, they could never touch. Or they could actually be the same line, which means they would intersect an infinite number of times. So these are the three possibilities that we will encounter as we solve systems of equations by graphing. Sometimes we'll have exactly one solution, which will look like an ordered pair x, y. Sometimes we will have no solution, and sometimes we will have an infinite number of solutions. So let's do some of these examples. So we have the equation y equals x. Remember, you can use any method you'd like to graph this. This is the same as y equals 1x plus 0. So our y-intercept is 0, and from there we go up 1 and over 1. So we can draw a line to connect those points, and then make sure we put an arrow on either ends. What about the second line, y equals negative 1x plus 2? So here we are going to have a y-intercept of 2, and then we go down 1 and over 1, like so. So this time, I'll draw a line here and connect them. Can you tell from this graph where these two lines meet? If so, write it down on your paper. Hopefully, you notice that the lines are intersecting here. This is the point 1, 1. So this set of linear equations has exactly one solution. And our final answer is the ordered pair 1, 1. Let's look at the next set of equations. So we have the equation y equals x. I'll go ahead and graph that, just like we did last time. It's the same equation. Another thing I forgot to do in the last example is to label our lines. So let's do that for this example. Then we have the equation y equals 1x plus 2. So remember we started our y-intercept, that's plus 2. And then we go up 1 over 1, and so on. So what do you think? Are these lines ever going to intersect? It doesn't look like it to me. It looks like these are parallel lines. So what do we write? Our final answer is no solution. Okay. How about the last problem? So again, we still have that first equation, y equals x. That has not changed. So we draw our points, and we connect them with a line, and we label that y equals x. Then we have 3x plus 3y is equal to 0. So let's use the x and y intercept method. So remember to find the x-intercept, we set y equal to 0 and solve. So if I set y equal to 0, what is my x value? Well, then my x value would be 0. So that means I have the point 0, 0. Well, what if I set my x equal to 0 and solve for y? So again, I cover this up. I divide by -3. Well, I also get y equals 0. So in this case, finding the x and y intercepts to plot this is not very helpful since I only generate 1 point. So what I'm going to have to do instead for this problem is I'm going to have to rearrange it and rewrite it in slope-intercept form. So remember the way I do this is by isolating the y term. Remember, the minus sign here belongs to the -3y. The 3x right now is positive. So I have to subtract 3x from both sides, like so. I have -3y equals -3x. I divide both sides by -3, and I have y equals x. Well that's interesting. Isn't that equation exactly the same as the first equation? It is. So if I try to graph the second equation, it's going to land right smack dab on top of the graph that I already have. And you can still kind of see both colors because I didn't do a great job of overlapping them perfectly. So we can label it also as, we can also label it as y equals x. So how many solutions does this problem have? Well, the answer is that there are infinite solutions. That's our final answer. Okay, so let's go back and label this. So in our first demonstration, we have one solution. So let's label our graphs. This is y equals x, and this is the line y equals -1x plus 2. Okay, over here we have the line y equals x, and then we have the line y equals x plus 2. And up here, we should write that there is no solution. Okay, and then here, we can write that this is an example of when you have infinite number of solutions that satisfy your set of equations, again, because you actually have two lines that are, in fact, the same line. So let's do a few more examples just to get more comfortable with this. So first we're given the equation y equals 2x minus 1. This has already been given to us in slope-intercept form, so we can start at the y-intercept, and then we can move up 2 and over 1, up 2 and over 1, using our slope to graph the remainder of the line. And then we can connect these points with a straight line, and we can label this line y equals 2x minus 1. But what about this other equation? We have x plus y equals 5. So we have to do one of two things. We have to either convert this to slope-intercept form, or we have to find the x and y intercepts. And just for this video, I will do this both ways, just so that you can see both are equally valid. in the future when you're doing these problems, you should pick one of these two methods and just stick with that one. So if I use the slope-intercept method, we get the equation y equals -x plus 5. If I go to graph that, I start at 1, 2, 3, 4, 5, and then we go down 1 over 1 from there. And then we can draw our line to connect these points. So looking at this example, can you tell how many solutions there are? Hopefully you can see there is one solution, and this is at the point 2, 3. So that is your answer. Remember, on a test or a quiz, you also have to support that answer by showing the graph. If you just write the ordered pair 2, 3 and you don't have a graph to support it, you're probably not going to get full points. Just as a matter of course, let's also show how to find the x and y intercepts. So remember, to find the x-intercept, we set y equal to 0. So we can use the cover method, cover up y, and we have x equals 5, which gives us the ordered pair 5, 0, which we've already graphed, as you can see over here. That's our x-intercept. If I wanted to find our y-intercept, that would mean I set x equal to 0. So if I'm looking at this equation here, I cover up x, and we have y equals 5. So that gives us the ordered pair 0, 5, which has already been graphed up here. So remember, either method is appropriate and useful if you're graphing in a line that's been given to you in standard form.